Alrighty. So the JK flip-flop that I built essentially follows this little truth table, the one found in the data sheet. Um, this one I think is for a rising edge, so this would be the positive edge, but in reality I followed this one for both, just switched the arrows. Um, and so the circuit looks a lot like this. We have 5 inputs and then 2 outputs. The clock signal, this would be for a positive edge. There's a circle on the negative edge. But yeah, so the code looks a lot like this for how I implemented it. So we have all the inputs, JK, the clock, and then clear and preset with negative logic. And then the 2 outputs. And the outputs are registers, so that way they can maintain their values. Um, this initial statement at the beginning basically is because without it, as it says, you need to initialize the registers for one. And so the value that you initialize them to um, depends on how you want to do it, essentially. Because as it says, -1 or 0 actually results in the count starting at 1 as soon as the clock begins. So it doesn't start at 0 or -1. But when you set Q naught equal to 1, then you can get it to start at 15 for at least half the clock signal. But then after that first, at least on the negative triggered clock, after the first negative edge, then it'll reset from 15 to 0, and then the count begins like normal. So it really depends how you want to do it. If you want to have all of them high initially, or if you want to have them the first one high and work around either of those. Um, yeah, that's what this first initial block is doing. And then down here, this is just the clock or clear and preset logic. And so they are triggered on a level edge clock because otherwise it leads to weird mistimings. And for one, if it's on a positive edge of the clock, it just keeps counting like it never even happened. And if it's on the negative edge of a clock, then it just has weird mess ups when you try and set it to clear. So setting it level edge means that basically the clear and preset signal happen whenever they happen, rather than worrying necessarily about the clock signal. They just come in, manhandle the bits a little bit, and do what they need to do. Yeah, this again follows very closely just the truth table over here, right? Um, and yeah, and then down here is the J and K logic block. Um, Again, this is the negative edge JK flip flop that's used for most of the modules. And so it starts on a negative edge of the clock, and then we have the case J. Either you could use J or K. I just decided to use J, and then within there's K blocks, which go through and again just follow the truth table here. They just yeah follow the outputs. For pretty much all of the counters in this, we're using the toggle. So J and K are both high. Um, and so that would be right here. And as you can see, we just set Q equals the complement of Q, and then Q naught equals the complement of Q again. Because essentially coming through this, it is sequential. So this is going to happen, and then this is going to happen. Um, you could probably just make this a Q naught and then have these as non-blocking assignments. And that might be a better way to do it to avoid timing errors in the future. But this design works fine for what we're doing. Um, but yeah, that would definitely be something to consider in the future is setting these to say the opposite of Q naught rather than the opposite of Q per se, or hard coding them in a better, more sensible manner. Um, and then yeah, there's a default that you should never arrive in. So these could be X's, but I just set them to zeros. And yeah, that's essentially the entire logic of this thing. Um, yeah, and then you just link these together. Here, I can go to the 4-bit counter. As you can see, you just link them together via their clock signals. So this is the clock signal, and it initially goes into the very first bit here. And then it comes through out 1, 2, 3, which is this guy. And then, as I said in the report, you flip that for the positive counter, right? Still uses the regular clock signal, but now you have not out 1, not out 2. However, you do still read out. You read the standard output, but you just feed in the complement of the output into the next clock signal. And yeah, that's about how it works.